Sure.
Right now, we are going to cover a couple of different things, right? One of the first things that we are going to cover is just a simple idea of what is orthographic projection. I'm going to do this for you up here so that you guys can see it, okay? You guys do not have to do this exercise. So what I'm going to do is I'm going to take this sheet right here that you guys all picked up. It's over on top of that thing, all right? And I'm going to cut it up and sort of fold it up so that you guys can see what the box that you will be making looks like. All right? This is called orthographic projection. This is an unfolded view that's using orthographic projection.
So I get close enough to where you can actually see what he's doing. I know it's not always conducive to personal space and boundaries, but even if you have to come around to the end, it'll help you.
Okay, so how many sides does a cube have?
6.
6. If we remove the bottom, how many sides does the cube have left?
5.
5. So there's 5 sides. So if you look at this thing, it looks like a plus sign, right? There are 5 essential sides there. And what orthographic projection is just essentially an unfolded view of what the three-dimensional object would look like. So as I fold these edges over, you guys should start to see the cube essentially emerge from this flattened shape. All right? And what I can do is, if I wanted to, I could take this thing and I could tape it up. And this is kind of a mini-me version, a tiny little version of what you guys are going to be doing. Okay? Does that make sense? See how that works? I'm not going to tape it up just yet. I just want you guys to kind of be aware. Each of the sides, right, has a dimensional relationship. So, for example, you guys were given 5 sheets of paper. I'm going to grab the same 5 sheets. And these 5 sheets of paper, I already had them here, didn't I? I did. Oh well. Sorry guys, it was a long weekend. Came back with my head a little fuzzy. So, these things all relate back to this cheater view that we gave you. This is the cheat, right? And so you can look at all the pieces and you can find those pieces in these. So for example, if I'm looking for that one that's got the 4 little cutouts in it, it's this one right here. Okay? So if I'm looking for the top, right, the roof plan, I can search through these and there is the roof plan. Okay? Or the top plan, the top view. So each of these, right, has a certain orientation, a certain way that it relates to all the ones that are around it. So in the same way that the top is at the center of this, I'm going to take my top here and I'm going to orient it right there. I'm going to set it down like that. All right? Then I'm going to look at the other pieces and see how they fit in with it. So here's one right here. It says the left side. So this looks to me like it might line up with this one. So you see these 3 cutouts here? That looks like it lines up with those 3 cutouts, right? All right, so I'll put that there. And I can even check it against this one, and yep, that looks like the right one. All right, now I'm going to look for this one, just like this, and it sits like that. Okay. Now, some people have, believe it or not, have turned it upside down, but you'll notice that things don't line up when you do that, right? These cutouts do not line up with those cutouts. It has to be set in a certain orientation. All right, continuing on. I've got this one here. This one doesn't matter because it's unilaterally symmetrical. It's symmetrical any which way you do it. So that one can go sort of like that. Right? And then finally there's this one, which is the front. And you can see when I do that that all of the cutouts that meet the top edge, that is, all of the cutouts that are on this, all point right to each other. Okay? That makes sense? All right, how many minutes we at, Mitchell?
We are at, where is it? 4:45.
All right, stop that.
Okay, stop.